Next, our program is our fifth program, that is finding the multiplication of two 16-bit unsigned numbers. So as usual, I will go to the TASM. This is the fifth experiment which I have told already. So I will use the command edit experiment 5.asm. So it is open now. With the help of title assembler directive, I have written the title of the program to multiply two 16-bit unsigned numbers. Now, as usual, I have initialized dot models. I have initialized the data segment with assembler directive dot data. Here, what is the purpose of our program? Program purpose is to find the multiplication of two 16-bit unsigned numbers. So whenever we multiply two 16-bit unsigned numbers, that time the result generated will be of 32 bit. Result generated will be of 32 bit. So whatever 32 bit is result is there, out of that 32 bit, higher 16 bit will be available in DX register and lower 16 bit will be available in AX register. So that will see. To store that lower 16 bit and upper 16 bit of 32 bit of result, I have taken two variables, result underscore h16, which will store higher 16 bit of the result, and result underscore 18, which will store lower 16 bit of the result. So we are having two numbers of size word size. So it will be it will be number one with a word size by using the we have defined with the help of assembler directive define word. So its value is 1234h, and we have taken number two with word size with a value 0100h. So that will be these two numbers. These are the two 16-bit numbers which we have to multiply, and whatever result is generated, that results will be of size 32-bit. Out of that 32-bit, higher 16-bit will be stored in result underscore h60, and lower 16-bit will be stored in the variable result underscore l60. I have initialized the code segment with these three instructions. Dot code move ax comma add data move ds comma add ax. So I have initialized the code segment. First, what I have done, I have taken number one in ax register. We know that for multiplication, default register one register is fixed for multiplication instruction is, that is AL or AX, which depends on size of the operation. Means if we are dealing with byte size, it will be AL is the default register, and if we are dealing with 16-bit, AX will be the default one register for multiplication instruction. Now second number I have moved to BX register. So I have two 16-bit numbers in variable, in register AX and BX. Now I will use the instruction mul BX. So with the help of mul BX, I will multiply two 16-bit numbers. So mul BX will multiply AX into, here what is going to happen? It will do the AX into BX, and whatever result is generated in that, DX will be having higher 16-bit and AX will be having lower 16-bit. So this is how the operation will perform. So after execution of mul BX instruction, the 32-bit result will be generated, and that will be stored in DX and AX register. AX will contain lower 16-bit and DX will contain higher 16-bit. For lower 16-bit, for higher 16-bit, we have a variable result underscore h16. So in that we have to put the result. So I have used the instruction move result underscore h16 comma dx. So higher 16-bit which is available in dx register will be copied to the variable result underscore h16. Same way, I will copy the lower 16 bit which is available in AX register to the variable result underscore L16, and I will terminate the program. So whatever result is generated, result will be of size 32 bits. So result will be is like this: 00123400H. So this is the 32 bit result. We know that each hexadecimal digit is equivalent to the 4 binary bits. Here we have 4 hexadecimal digits. 4 into 8 is 32 binary bits. So yeah, this one is the result which is stored in DX register as 0012H, which is the higher 16 bits here. These are the higher 16 bit. These are the higher 16 bit of the results, and these are the lower 16 bit which will be stored in X register. Which will be stored in X register. That we will check when we will execute the program. So this is the program to multiply two 16-bit unsigned numbers. Go to File, save the program, come out of the editor window, type file name is expt5.asm. So there is no error and there is no warning. Next, t-link, file name is expt.obj. No, so I have written expt.obj. Actual file name is ext5.obj. I should write. So that's why the file we have got the error unable to open a file. So from start we have to write again. From file name is expt5.asm, t-link, file name expt5.obj. It will link the object files. So see the here. Whenever I did the mistake of file name, that time I got the error unable to open file expt.obj. Here I have done correctly, so there is no warning and there is no stack involved in it. Next is td, file name is expt5.exe. Execute it, click on OK, expand this, execute step by step. Observe here carefully AX and BX registers. In AX register we got first number 1234H. In BX now we got 0100H in BX register, and now we will perform the multiplication instruction. See here, multiplication has done. The 32-bit result generated will be available in DX as well as AX register. So DX will contain 0012H and AX contain 3400H. This is our results. So this is how the result is generated. If you observe carefully, here O flag is set to 1. O stands for overflow flag. As the overflow flag says to 1 because we have done 16-bit operation and we got 32-bit result. So that's why there is a overflow. That's why overflow flag is set to 1. So this is how we can multiply 16-bit number by 16-bit number, unsigned numbers. Terminated. Okay. Go to file menu. Come out of this window. So this is how we can do multiplication of two 16-bit numbers. Next experiment is to divide the word by byte. In that we have two practicals, dividing 32-bit number by 16-bit number and 16-bit number by 8-bit number. That we will see now. Go to edit. I have saved this as experiment 6a dot asm. So this is the program to divide 16-bit number by 8-bit number. Before that, you just go through div instruction, which is same as that of same, or we can say reverse as that of multiplication instruction. So as usual, I have written program with the program title with the help of title assembler directive. I have written dot model small dot data in data segment initialization. Now here dividend for dividend I have taken variable div16, which is of size 16-bit. We are dividing 16-bit number by 8-bit number. Okay, and divisor we are taking in. For divisor, we have taken variable divisor, which is of size byte, in which we have data 0f00h. So which is a divisor. Okay. Now after division, we will get quotient and remainder. We will get the quotient in AL register and we will get the remainder in AH register. So to save that quotient and remainder, we have taken two variables of size byte. Because we know that whenever we are multiplying byte by byte, we will get 16-bit result. That will be the dividend. That will be the dividend. So we will get quotient in as a 8 byte, as a 1 byte, and remainder as a 1 byte. So I have taken two variables, quotient and remainder. We don't know the result. That's why I have put question mark here, and they are defined with the help of assembler directive. Define means the quotient is a variable which is of size byte only. Okay, now I have initialized the code segment with the help of these three instructions. Move dot code, starting of the code segment, move x comma add data, move ds comma x. Now what I have done, I have taken first 16-bit number into the variable, into the register AX. So I have written instruction move AX comma div16. In div16, I have data 1, 2, 3, 4H, which is the dividend, and it will be copied into the variable into the register AX. Okay. Now after that, I will copy the divisor in the variable BL. So dividing AL by BL. So as I told that for multiplication and division instruction, whether it is byte or word operation, the default register is fixed. That is AX register for 16-bit operation and AL register for 8-bit operation. Or we can say that AX register for word operation and AL register for byte operation. Now I will use the instruction divbl. divbl. Here what is going to happen? It will divide the number which is available in AX, will be divided by BL register. So it will generate the result and it will generate quotient. That quotient will be available in AL register and remainder will be available in AH register. So whatever result we will got after this execution of this instruction divbl or will be available in AL and AH registers. So AL contains the quotient and AH contains the remainder. So we will move that result in the two variables quotient and remainder. So we have written instruction move quotient comma AL. The content of AL is nothing but the quotient of the division which is performed earlier, that is here, and it will be copied into the variable quotient. Now next, the remainder will available in H register will be copied into variable remainder. So I have written instruction move rem comma ah. After that, I have terminated the program as our operation is finished. Move h comma force h int 21h end. Go to file menu, save the program, and after that exit. Write down tasm xpt6a dot asm. So there is no error. T-link file name is ext6a dot asm. Sorry, dot obj I should write here. After that td file name xpt6a dot exe. So we came to the executor window. See, observe here AX register and BX register. So whatever result is generated, that will be in AL and AH only. So if you multiply, now we will do the step-by-step execution with the help of F8 command. See, first data 16-bit data came into the AX register, that is 1234H. Next is next is BX comma second 8-bit data, that is 1 byte data will be copied into the BX register. So whenever we are copying BX and we are dividing by BL, so 16-bit divided by 8-bit. So you might think that it will be a size mismatch, but at this time the compiler or the processor managed to do sign extension, means it will add 0 at the uh, remaining 8 bits MSB bits. So that's why here for BX the value comes as 00 FFH. Actual our data is FFH only, but the compiler or we can say processor added sign extension 00H. Execute next instruction. So we got the result after the division. The 12 is the quotient and 46 is the remainder. 12 is the quotient and 46 is the remainder. As we know that after division of div bl instruction, here execution of division div bl instruction, the result generated available in AL and AH register. AL contains the quotient which is 12 and AH contains the remainder which is 56. So this is the result of the division by of 16-bit number by 8-bit number. In the program, terminate it, click on OK, come to file menu. So this is how we have seen this is how we have taken division of 16-bit number by 8-bit number. Now we have to go for division of 32-bit number by 8-bit 6 numbers. That program I have stored with second part of 6x. So it will be edit 6b.asm. So this is the program which with the help of which we will divide 32-bit number by 16-bit number. As usual, I have taken dot model small and I have initialized data segment. Now here my data is 32-bit. Now that has to be, and that 32-bit data that has to be divided by 16-bit data. For 16-bit data, there is no problem. We have instruction, we have register 16-bit registers. But to store 32-bit data, we have to use 2 registers. As we know that we can take the variable or we can define the variable with the help of DD assembler directive, that is the double word assembler directive. Okay, but we don't have registers. We can define the variable, but we don't have registers. So that's why what we will do, we will divide that 32-bit data in two parts. Now for that, I have taken two variables, h higher part of dividend, that is higher 16-bit of the 32-bit data, that will be say 1234H is the higher 16-bit, and 5678H, which is a lower 16 bits. So these combiningly will form the number 1, 2, 3, 4, 5, 6, 7, 8H. So this is our actual 32-bit data, and that has to be divided with the divisor, with FFFFH is the divisor. So that FFFF should be divided by 1, 2, 3, 4, 5, 6, 7, 8H will be divided by 4 times FH. Now for that, I have taken one variable divisor, which is size, word size, which is defined with the word size, and I have written 0 FFFF 4 times FH, which is a divisor. Now here I have taken 0. This is not O, it is a 0. Why it is 0? Because while giving the instruction to the compiler, we must have some binary code. If I am not writing 0 before FF 4 times FH, it will treat, the compiler will treat this number, 16-bit number 4 times FH as a instruction. And there is no such instruction in the set of instruction set of 8086. So it will give an error. For that purpose, to avoid that error, we will insert 0. So now after 0, whatever figures are available, that will be treated as data for the variable divisor. That will be stored in the 2 bytes of the memory. As we know that after division, we will get quotient and remainder. Now, whenever we are dividing 32-bit by 16-bit, we will get 16-bit quotient and 16-bit remainder. So we will have 16-bit quotient. So for that purpose, I have taken one variable quotient, which is of size, word size means 16-bit. Currently, I don't know the result. That's why I have taken question mark. After that, I have taken one variable remainder, which is I have taken one variable remainder, which is of size, word size only, because we know that whatever result is generated whenever we are dividing 32-bit number by 16-bit will be of size, word size only, that is 16-bit. So that's why quotient and remainder has 16-bit size. Okay. Now I have initialized the code segment with the help of these three instructions. Dot code, move x comma add data, move ds comma ax. Now here I have taken higher byte of higher 16-bit in dx register. So whatever higher 16 bits of the 32-bit data available will be copied into dx register. So I have written instruction move dx comma HDIV. In HDIV we have data 1, 2, 3, 4H. So after execution of this instruction, the content of dx register will be 1, 2, 3, 4H. Okay. And after execution of this below instruction, so a contents of AX will be 5, 6, 7, 8H. So combiningly it will become 32-bit numbers. And I will after I will move the divisor in BX register. So after execution of this instruction, move BX comma divisor, the content of BX register will be FFFFH. Whatever I am writing after giving semicolon will be treated as and it will not be executed. So this is for our understanding only, not to write, not to execute. And I will use the instruction div bx. After in this instruction, what is going to happen? The operation going to happen is that dx as to ax will be divided by bx, and after that it will generate the result in the terms of quotient and remainder. So quotient will be available in ax register and remainder will be available in dx register. After that, I have terminated the program with the help of three instructions: move h, 4ch, int, 21h, 21h, and end. So this is how we will divide 32-bit number by 16-bit number, and we will get the quotient and remainder in x and dx register. So we will check that program whether we are written correct or not. Come out of this editor window, type tasm, file name is expt6b.asm. There is no error. It means that our whatever instructions we are written, that whatever programs we have written, that is correct symbolically. Now key link the object files. File name is expt6b.obj td. File name is expt6b.exe. Click on OK. Extend this windows. So here observe carefully. We will see the result. Start with F8. So higher 16-bit we got in DX register, that is 1234H. F8, press F8. We got next instruction is executed. So we got, after execution of this instruction, move x comma whatever in bracket we have written, that is that value we are having 5678H will be copied in AX register, so that 5678 will be copied in the AX register. After that, this instruction will be executed: move bx comma in square bracket 0012H. At the offset address of 0012H, we know that we are having data 4 times fh. So that should become in bx register here. Press F8. So we got bx as a f 4 times fh. Now we are executing div instruction. Press F8. So we got the result in dx and ax register. In dx we have remainder and in x we have quotient. So this is the quotient and remainder of the 32-bit number, that is 1, 2, 3, 4, 5, 6, 7, 8, 8. Whenever it is divided by 4 times fh, the division is 1, 2, 3, 4h, and sorry, quotient is 1, 2, 3, 4h, and the remainder is 6, 8 ACH. Terminate the program. Okay. So this is how we have seen that how to go to file menu. Wait. This is how we have seen that how to divide 16-bit number by 8-bit number and 32-bit number by 16-bit number. Thank you.